Stacks are a fundamental data structure in computer science and programming in general. And if you've been programming for a while, you've probably come across stacks before. But if you are new, a analogy that I like to use to explain it is a stack can be thought of as a deck of cards. So if we have a deck of cards, we play cards, so we put cards on top of one another. You can't place a card at the bottom or the middle because then you have to lift everything up, put it in the middle, to put everything down, it's a mess. So usually you just put the cards on top of one another. Similarly, if you want to remove a card from the deck, you remove from the top, not the bottom or the middle. And a stack behaves very, very similarly in this way, and these properties of stacks make it very useful in real-world applications. So here we have a little card called 1, and if I was to place a card on top of 1, like this, we're building up that deck of cards. And this process of adding cards on top of other cards, or adding elements on the top of a stack, is called pushing stuff onto the stack. So here we pushed 4 onto the stack, and now we pushed 5. If you want to pop elements or remove elements from the stack, we just pop them off. And we always go from the top. So you can't pop from the bottom or the middle, you always pop from the top of the stack. And there's one final operation called peek. Peek tells us the current element at the top of the stack. And this can be, right now it's 3, but if we took off 3 and we had 1 and 2 in the stack, then it'll be 2. So I'm going to go over how we can program a stack in C, a really basic stack, so we can understand how these operations work. So here I've got a simple hello world program. I've included stdio.h, standard lib, and standard bool because I like having booleans. So we're going to create a struct here called stack. And a stack is really simple. We just need 2 things. We need an array. So in this case, I'm going to be storing integers. So we'll just call this stack. And then we need some max size. So I'm going to set it to 10. If you are programming this and you're going to use it in a project, it's probably better to allocate it on the heap. And we're going to have max size, or we just say size. Alright, so this is the maximum number of elements in the array, which is going to be 10. And if you are going to be using this in a project, I'll probably allocate the stack on the heap. So this array right here will be allocated in the heap, and the size will be based upon this size here. However, I don't want to put this 10 here. I'm just going to make a macro here called max stack size. I'm going to set that to 10. And then here we can just use max stack size. So if I'm going to make my stack here, we're going to call it stack. My stack is equal to 0, and then I'll set the index to be -1 at the start. So if you guys aren't familiar with this is the initialization syntax in C. So 0 basically means this stack's going to be full of 0, so it's just completely emptied out. And -1 right here represents the value of size, which is going to be set to -1 at the start. Now we can go over the 3 operations stacks have, which is push, pop, and peek. We'll start off with push, so we can say, let's say boolean push. We have to pass in a stack, and we're going to pass in a pointer to the stack because we're editing the stack in this case. We're going to first check if the stack size is less than the max stack size, right? And if it is, that means we've got space on the stack to add elements. And I almost forgot, we have to give in the value you want to put in the stack here. So we say stack at stack, and stack at size is equal to value. What this means is we get the stack, so this array right here, and then the current point, so stack at size, that index is going to be empty, so we're going to, because it points to the top of the stack, so we're going to put a value there, and then we just increment the size variable, and we're just going to return true because we successfully put a value on the stack. And if we fail, to return false. So let's quickly test it out. So if I do printf pushed onto the stack, and then we're going to return a boolean. So let's just say my push onto my stack. we are putting a ellipsis, not ellipsis, what's it called? Swirly thing. We call it swirly thing. So ampersand, yeah, ampersand. We put ampersand there because we're passing the memory address of the stack variable. And that's how you put 5. And then let's push it a bunch of times. So you compile, we run. So it succeeded. I'm pretty sure that's less than 10, right? So let's add a couple more. Okay, as you can see, once we reach 10 elements, I'm pretty sure that's 10. Yeah, that's 10. So once we push 10 elements onto the stack is completely full, and so push just returns 0 because we can't push any more elements from the stack. Now the next operation is pop. So I'm going to return an integer, which is the element we pop off. In the case that we can pop the element of the stack, we just pass in the stack. Once again, we pass in the pointer to the stack because we are going to be manipulating the memory in there. So we first check if the stack is empty. In that case, the stack size is going to be less than 0. So if stack size is greater than -1. Yeah. So if it's greater than -1, that means we've got data in the stack we can pop off. So we do stack size is equal to int. Let's call this element. Just call it value. That's the value right there. Then we just decrement the size pointer and we return value, right? Otherwise we just return 0. And if we return with 0, that means that there's no element there. So if we try doing this again, if we push onto the stack, let's say push my stack 10, then I push onto my stack 20, then let's printf pop. You run pop on my stack. Okay, that's a bit weird. Oh wait, yeah. So the reason we're not getting what I was expecting here was for it to pop 20 first, then 10. The reason we've got 0 here is because we are basically indexing -1 here because the initial value of size is -1, as you can see there. So we have to increment size first, and then if this works, yeah. So we pop 20 off because this is the most recently pushed element on the stack. So it pops off 20 first, then 10. If we try popping again, we get 0. So the stack's empty. Finally, we have peak, and peak, we can just pass in the stack here. So here we're not passing in the memory address of the stack, we're just making a copy of the stack that we have. So we just make, when we pass in, whenever we run this function, we just pass in a copy of this stack, and then what we just do is, if stack size is greater than -1, so it's not empty, we just return stack of size. Otherwise, we just return 0, right? Because well, the stack's empty, nothing else to return. So if I just do printf peak, then we just remove the ampersand. And then if I was to pop something off the stack, let's say, then let's peak. Yeah, so since we aren't passing a pointer in, we don't have to dereference it with the arrow operator, we can just use the dot instead. So here we go. When we first peak, we had 20 at the top, then we popped 20 off, then we had 10 at the top of the stack. We popped 10 up, and we popped 10 off the stack, and then we got nothing left in the stack, so the stack's empty. So we got 0. And that's how we make a basic stack. So you may be asking yourself, what's the point of stacks? I mean, they're quite interesting, but I don't see any practical usage. Well, this is a practical example. Reverse Polish notation. It sounds quite fancy, but I'll walk you guys through it. So here we have a mathematical equation, 5 plus 3 times 2 minus 6. Now, how would a computer go around solving this? Well, there's two parts to this problem. One is getting the equation in a form where the computer can pass it, and then the actual process of passing it. And we'll go through that. First off, how does the computer get this into a form it can execute, or understand at least? And that's called bracketing. So you've probably come across the idea of BIDMAS, because operators have precedences. For example, a times should be done before a plus or a minus. So here, we will just put brackets around each of the operators. So times should be done first, so we put brackets there. Then we have plus, we do plus next, and we can do minus last. The order of plus or minus does not matter, as long as times comes first, because if you know BIDMAS, plus and minus have equal, what's the word I'm looking for? They have equal precedence. Well, the order does not matter in which you do a plus or minus. It gives the same answer. So we have this as the bracketed equation. Now we move the operators in each of the set of brackets to the left. So to the right, not the left, to the right. So here we move the times to the right in the red bracket. We move the plus to the right in the green bracket. And we move the minus to the right in the blue bracket. Once we remove all the brackets, we get this new funny looking set of numbers and symbols. Now, for us as humans, this does not make any sense, but if we order them left to right, it can start to look like a stack. And this is important, because if we make this set of numbers a stack, then we create another stack on this here on the side. Let's call it value stack. We can start to solve this equation, and this is pretty cool. So we take 5 from the top of the stack and we put in value stack. We repeat it with 3. We repeat it with 2. And now we reach the times symbol. Let's see what happens. So we reach times. What we're going to do now, we take the first element of the top of the stack. We take another element of the top of the stack, because time needs 2 values, or 1 on each side. And we calculate the result, and we get 6, right? So we put 6 back onto this main stack at the top. Now we put 6 back onto this stack, and we get plus. So we take out one value, we take another value, because we need 2 values to add together, and we get 11. We put 11 onto the top of the stack. Now you may be asking, why are we doing this? What's the point? Well, we're actually solving the equation. So the rule is, whenever we have an integer or a number, we just put it onto the value stack. And once we reach an operator, we pull 2 values off the stack, and we just perform the operator on them, or the operation, and then we push the result back onto this main stack on the left. Now, you could be thinking, well, what if we don't have 2 values in the value stack? You don't have to worry about that, because the process I showed you before of bracketing, if the equation originally is correct, we will always have 2 values before we run each operator, so this operation will never fail. So here, we go back, we put 11 onto the value stack, we put 6, and we have minus right here. So we just take 6 out, put it to the left, we take 11 out, we put it to the right, and we end up having minus 5 as our final result. So I'm going to go around and program this reverse Polish notation function. And by the way, the name of that notation, where you had these weird numbers before, that's called reverse Polish notation, and this algorithm uses stacks to solve this equation. So here we're going to program the reverse Polish notation function. So here, let's see, we're going to return an integer, which is the final value, or the result of the result of the evaluating the equation. Let's call this calculate RPN, reverse Polish notation. We're going to pass in a stack. Now we don't have to pass in a reference to the stack, because we don't have to edit the stack itself. We can edit it locally, and those changes don't have to be made to the main stack. So first off, we're going to have a while loop. So while true, and we are just going to first you have to get the integers off the stack. So let's say pop stack, right? And a cool thing about C is a character can be interpreted as an ASCII value. So we could have a character like plus or minus or a symbol like that, and we can just put that into the int array and it'll be fine because we can just convert it to a character right here. So character is equal to char. Just by typecasting it, we get the, because this num will just hold the ASCII value of the symbol, and then we can just cast it back to a character through the static typecasting. Once we have the character, we're going to first check. So if character is equal to plus or character equals minus or character equals divide or character equals multiply or times. So if it's one of these four characters, then we know it's an operator. If it's not one of these four characters, then number is just a number. It's not an ASCII value for a character. We can then use a switch case statement. So we can say switch character, right? And then if it's plus, we will just do, we have to perform the operation. I'll leave this part empty for a sec, and you'll find out why in a minute. Let's fill out the other ones. So we have plus, minus, times, and divide. Okay, so we know that we have an operator here, right? So in order to perform an operation, we need values, and those values will be stored in a values stack. So we have to create another stack. Here, right here, we call it values, and this will have 0 as that. It'll have a maximum size of, as you can see, it'll have this maximum size of 10, which is the same as this stack, right? For now, we're going to then, in this value stack right here, we're just going to do int first number is equal to pop values. Then we're gonna have second number. Or let's call it a num instead of number. It's less typing. So you've got two numbers that are values. Now, if you're wondering how do we get these values into, how do we get these numbers into values, we'll code that in a minute. That's going to be part of the else statement. But for now, just assume that we've written the code for getting the values in. So here we're just going to do first num plus second num. I'm just going to change it based upon what the operation is, right? So here we just get these values, and then we're just going to return these, not return, that's the wrong one. What are we going to do? We're going to push, yeah. So we're going to push, what happened here is we got the new values, right? And we're going to push these onto the original stack again. Here we go. So, in the case that the num that we got is not a character, so it's not an operator, what do we do? So, we have two options here. Either this means that we have, this could be the last element in the stack. Actually, before we get to that, I'll just cover the main case. So there's two cases. Let's say this, the first case is just another number we have, so we can just push this onto the stack. So we just say push onto values num. So this is where we're getting the values there. So first num and second num, it's coming from this function right here. Okay, so we faced a little bit of an issue there, but what happens here is we push the new number onto the values array, which is the first case we can have. However, if the num array is, the stack is now empty, so the stack we passed in right here. If it's empty now, then what does that mean? What it means is if the stack's empty, then this is the last number in the stack. And the last number in the stack is the result of the operation. So this whole equation, the result of evaluating all the expressions, this is the final result. So if we want to leave the function at this point, so we just return this number right here, right? So stack size equals 0, just return the number. So if you run the code now, as you can see, let me show you the print statements. There's a few print statements there. We get RPN result -5. So this is how we can actually use stacks in a practical way. is for RPN, and it's got many other use cases, but this is just to show you what you can do with this data structure. It's very useful and it's very powerful, but at the same time it's very simple. So I hope you enjoyed this video. I made a video last week about a cool trick with variadic functions in C. If you like this video, you probably like that one as well, so go check it out. And subscribe to the channel, leave a comment, and like the video please if you enjoyed. Thank you for watching.